Welcome to the XJO podcast. Here we explore journalism innovation, including how academics share their research in new ways that target wider audiences. This podcast showcases some of the researchers on the XJO team. I'm Macenzie Rebelo, and I'm an RA with XJO. Joining me now is Robert Clapperton. Robert is an associate professor in the School of Professional Communications at Toronto Metropolitan University. Robert is the project lead of leveraging transformer neural networks for detecting misinformation in journalism. Hi, Robert. Thanks for joining me.
Well, thank you for inviting me. It's a pleasure to be here.
So how does your project fall within the realm of explanatory journalism?
I guess it kind of falls in a bit of a tangential way. Our project is looking at trying to develop ways to find misinformation in journalism. So looking for pseudo-journalistic properties that put out information that has a different agenda than most journalism does. And a lot of times they kind of frame it as explanation, where they're trying to explain a conspiratorial sort of way how a certain problem exists, or how a certain politician is acting a specific way, and they're doing it for an agenda to try to promote what their beliefs are. So the explanatory journalism that's being studied in other parts of the overall project are more looking at how is journalism like the conversation, be able to explain complex issues. We're kind of looking at the mirror of that, but being put out by non-reputable sources and putting their sort of so-called explanations out. So we're trying to figure out a way to use machine learning to try to see if we could ferret out that kind of misinformation that is, in a way, trying to mock itself as explanatory journalism.
How has your previous research informed your current project?
Well, for the last 10 years, I've been working on artificial intelligence, specifically natural language processing, and trying to develop ways to engage it in education, where in my other research projects is trying to see how could we use machine learning and right now generative AI, especially large language models, productively in education. Right now, the biggest fear is how it's being used as a way for students to avoid having to write and demonstrate critical thinking and going to ChatGPT for the answer to everything. But on the flip side, generative artificial intelligence could end up being a very productive tool in providing ways for students to engage with content, to place, enter simulated roles, to have a chance to take theory and things they're learning and practice it in a real feeling setting. So for the last 3 years, I've been working exclusively on generative AI as part of original the beta projects around OpenAI that led to ChatGPT, and was experimenting with that and trying different applications of creating ways for students to engage in arguments, to students to engage in ways of trying to persuade a bot and having the bot try to persuade them. So it kind of morphed into this idea of how can we use machine learning then on existing text to try and find misinformation.
How did you go about researching for this project?
Well, I mean, there's the research you have in developing something like this. You need to look at prior work. What have people done? Most of the work that has been done around machine learning and misinformation has been trying to build a generalizable neural network where they train it on misinformation to try to get it to recognize it. So we looked at what had been done out there. We contacted people that had large data sets of misinformation. But then most of the research work was more experimental, where we would try to create our own transformer neural network to identify the sort of building blocks of explanation, things like claim and backing, and then train the neural network to recognize that part of the article, and then have that, and then train that on what is good and misinformation, and see if it can develop the ability to contextually pull out information that's questionable. So most of the research is on a more experimental basis. You try something, see if it works, you go back and fix what didn't work and try again.
And what kind of conclusions did your research come to so far?
Number one, it's very difficult to create a transformer neural network that can get the nuance of the context that's required in order to determine whether something is misinformation or true information. And but what we have found is that by breaking down, having the neural network not start at the level of true or misinformation, but have a start at the level of claim and backing, being able to determine what the primary claims are in an article, what the secondary claims are, what are being used to back up with it. Then when the attached to a large language model that can look at all sorts of other information to sort of verify it, we think we have a pathway where we can develop the neural network to be able to analyze articles and kind of give a rating on their truthfulness, and or a rating potentially, we haven't got to that point yet, or whether of how much potentially could be misinformation. So we definitely are seeing a path there. It's still very much in progress.
So tell me about a challenge you've encountered while working on this project.
When we first started working on this project, large language models were not as powerful as they are now. We started working on this project, was basically GPT-2, and GPT-3 was the new OpenAI model that was there. And we worked on some of and we used other large language models like BERT and Bloom in sort of an experimental phase. And they weren't powerful enough yet for us to take what we found, our neural network would detect in terms of claim and backing, and be able to do the kind of powerful computing work it would need to do in analyzing all of the other stories that could potentially exist around these topics and come up with a rating. But it's, as we move forward, and now we're into using much more powerful versions of BERT and many, many more parameters, so it can actually do more of the computational work to try and get out some of that context, so we can make a statement of whether or not it's true or not.
And where do you see the future of this project going?
Right now, we're gonna put the neural network that we developed on claim and backing make it open source and release it, and we're gonna write a paper on that aspect of it. And then the next phase of the project will be integrating it much more seamlessly into a large language model. We could start being able to put articles in and get reports back as to whether an article has misinformation in it or not. That part will need to run through a number of experiments and get to a level. The ultimate goal would be something where it could be an application that scans news and puts a report together as to whether if certain information is not factually true, and basically do it by showing proof. Right now, there's lots of things that can say, we think this is misinformation. There are a lot of projects working on that. We're trying to get to one where we can say, this is why it's not true. But that would be the future. I think maybe another year and a half.
What are some examples of the type of misinformation you're studying?
Well, we trained the neural network on some general misinformation databases that have been created. So a lot of them are social media posts, and what they've been human annotated. So a human has gone through them and looked at them and kind of coded them as being misinformation. So that's kind of the starting point of training the neural network, just to kind of recognize it, but it's not the kind of the final training method.
Is the neural network better at recognizing some types of misinformation rather than others?
Yeah, the neural network itself is just trained to detect when someone's making a claim, like a factual claim or an opinion claim. So it's making a claim and it's providing backing to support that claim. So we're just using that as kind of the building blocks and the indicators that we then use in further analysis to be able to pull out potentially fake information.
Ideally, what type of misinformation rating scale would be used?
Yeah, I think what you're talking about would kind of be where I would eventually work towards. If we were to run the application 24 hours a day using the claim detecting neural network, analyzing the claims for diffusion, then the neural network would probably get better at understanding what's true and not true. But that's kind of not the point that we did. And we trained the neural network on information that's been humans have said this was fake. And the neural network, inside the neural network, it's looking for indicators that might indicate that something's false, but it may not as well. So it's sort of an experiment that we have to run to see if you put tons and tons of fake information through a neural network that you're training to look for claims, and then you build an application to sort of create a way to identify those claims and sort of mark them as true or not true, and then feed that back into the neural network. Could the neural network then evolve into being able to detect fake and true news? That's still very much up in the air in the research project itself in terms of whether we can prove that out through experimentation.
That was Robert Clapperton, the project lead on leveraging transformer neural networks for detecting misinformation in journalism. To learn more about Robert's work and the XJO project, visit us at tmu.ca/explanatory-journalism.